Good morning. We will start session 7 on chapter mensuration. So today's session will be on based on volume. So till now we understood about area, and that surface area, that is total surface area, and curved surface area or rattle surface area. Let's talk about volume. First one is theoretical. So I'll just mark this in the book. You can make a note. Given a cylindrical tank, in which situation will you find surface area? And in which situation you will find volume. This you should know. We know that whenever we have area is nothing but the region bounded, correct? And volume is something which will fill in it. Space occupied is always the volume. If this is a thing, if I have to cover, see what is the thing what I have to cover it? Whole, it is surface area. How much ink can fill in this pen? Whole pen, that is nothing but volume. So here, first one, to find how much it can hold, just copy the question as it is, put a hyphen and write, to find how much it can hold, it is volume. Number of cement bags required to plaster it, surface area. See, surface area when we talk, it can be also total, it can be CSA, curved surface area. Now surface area is total. How much bag is required to plaster it? Now plaster it is in the sense outer part area we wanted. Surface area we will write. To find number of smaller tanks that can be filled with water from it. So suppose you imagine that I have a bigger tank. So number of smaller tanks, that means assume that I have smaller buckets. With that bucket I have to fill water and fill the tank. That means I need to know the volume of the tank here. So children, first one is volume, second one is surface area, and third one is again the volume, right? I think it is very clear. Second one, diameter of a cylinder is 7 cm, figure is given, and height is 14 cm. Diameter of the cylinder B is 14 cm and height is 7 cm. Without doing any calculations, can you suggest whose volume is greater? Now, just imagine, this is a very simple technique what you can also try at home. A glass what you have whose base radius, what you can say, or diameter is more but the height is small, whose base radius is very small and the height is quite bigger than the previous one. So, accordingly when you see here, which can fill more volume, it's easily we can say it is B, right? Container B. Verify it by finding both the cylinders. Usually they will not ask you such questions orally. Here they have given. So let's write the dimensions of A and B, find their volumes and find their surface area. Now again, surface area means what, children? Total surface area. So this is figure A. And this is figure B. So here it is 7 cm and this is 14 cm. So this is 14 cm and this is 7 cm. This is A and this is B. So first of all I will write here cylinder A. Volume, okay, before we write the volume, let's write the dimensions of cylinder A. Diameter is equal to 7 cm. Therefore, radius will be, children, 7 by 2 cm. Again, remember, do not write it in decimal. Keep that in fraction only. Then they have given height. Height is 14 cm. What is volume formula of cylinder? Pi r square h, right? Pi is 22 by 7. R is 7 by 2 into 7 by 2 into 14. 7 and 7 will get cancelled. 2 ones are, 2 11s are, 2 ones are, 2 sevens are. So it is 11 into 7 sevens are is 49. 11 into 49, when you multiply you will get 539. So simple, 49 tens are and 49 ones are. I have already told you how to go with such type of calculation. Since it is volume, children, centimeter cube. This is for cylinder A. We'll find out surface area also. TSA 2 pi r of r plus h. So 2 into 22 by 7 into 7 by 2 into r is 7 by 2 plus h is 14. Don't cancel, 2 ones are 2 sevens are here. 7 and 7, 2 and 2 will get cancelled. 22. So this is 7 plus 14 into 2. 28 upon 2. You can do that here. 2 ones are 2, 11s are. So 11 into 35, right? So 11 35s are, you will get answer as 385 centimeter square TSA. This is of cylinder A. Let's find the same thing for cylinder B and then give the concluding answer. For cylinder B, what is diameter? 14 centimeter. Therefore, radius will be 7 centimeter. Height is equal to 7 centimeter. 14 by 2, 7. So, let's find out. Volume is equal to pi r square h. So, 22 by 7 into 7 into 7 r square into 7. 7 and 7 will get cancelled. So, you have here 22 into 49. Here it was 11 into 49. So 49 into 20 you can do. Then 49 into 2 later. You will get answer 1078 centimeter cube volume. Last is TSA. 2 pi r of r plus h. Okay, so this is 2 into 22 by 7 into r is children 7 again, r plus h 7 plus 7. So 7 and 7 will get cancelled. 22 twos are 44 into 7 plus 7, 14. So here it was 11 into 35. So where we have 44 into 14, answer is 616 centimeter square TSA. Let's give the concluding answer. Verify by finding the volume we have done. Check whether cylinder with greater volume also has a greater surface area. First give a conclusion. From the above calculation we confirm that cylinder B has a greater volume. Also the cylinder which has, compare the surface area, which has greater surface area, this one only. So the cylinder which has greater volume also has a greater surface area. Please keep the same conclusion. I repeat, first we write cylinder B has a greater volume, then the cylinder which has a greater volume also has a greater surface area. Very clear, children? Let's quickly find the next one. Sums are quite simple in this exercise. Okay, so third one, find the height of the cuboid. Question mark, yeah. One more thing I completely missed. Okay, second one we had written cylinder A. So here before we start anything, what we have to write, children? Cuboid. So the given figure is a cuboid. Previous figure we wrote it, cylinder A and cylinder B anyhow. So find the height of the cuboid whose base area is, so I will write base area only here. What is base area? Length into breadth. Base is nothing but of a rectangle. That means it is length into breadth, which we have to know. Is 180 centimeter square. And volume is 900 centimeter square. Find the height. Volume is equal to length into breadth into height. That is what they have given. Volume is 900, but if you don't understand what is base area, then you cannot substitute here. What is length into breadth given as 180 into h. H is equal to 900 divided by 180, 0, 18 ones are 18 fives are. H is equal to 5 centimeter. A very simple question, but you should know what is that base area here. It is length into breadth. We'll go to the next one. Fourth one, a cuboid of dimension, so mention it is a cuboid of dimension, length is equal to 60 centimeter, breadth is equal to 54 centimeter. Now they have given dimension 60 by 54 by 30. Understood that it is length into breadth into height, and height is equal to 30 centimeter. How many small cubes with side 6 centimeter can be placed in the given cuboid? Now what is this question is, you have a cuboid of this is the dimension. Assume that you have a carton box. It's a cuboidal shape, right? Quite big carton box. This is the dimension. Then I have assumed that small dice. Cube. It's a cube form, right? Dice is a cube form. How many such dice I can fill in them? I can fill 10, 20, 30. Okay, assume that dice is almost this shape one. Okay, you have this Rubik's cube, what you say now? That's a cube only, correct? So how many such cubes you can fill in them? That means you should know the surface area of one cube into how many such cubes you can place it. That we have to find. That is the meaning of this question. So let's first find volume of this. Means we'll understand how many such cubes we can fit in them. Space occupied, right? Volume is equal to length into breadth into height. That is 60 into 54 into 30. A bit calculation what you have here. So it is 97200 centimeter cube. Volume of a cuboid. Keep it as it is. Next what you have a cube. How many small cubes of side 6 centimeter? A is equal to 6 centimeter. Volume is equal to A cube. That is equal to 6 cube. 6 cube is 216 centimeter cube. Right? Now, I will write here N into volume of cube is equal to volume of a cuboid. Is that fine? Number of cubes of volume, what I know that cube into number of such cubes will fill the volume of the cuboid, the carton box. So N is equal to volume of a cuboid divided by volume of cube. So what is volume of a cuboid, children? 97200 divided by 216. Calculate this, divide this. I'll give you the direct answer, 450. 450 cubes of side 6 centimeter can fit into what they are given. Let's see. How many small cubes with side can be placed in the given cuboid? 450 cubes with side 6 centimeter can be placed in the given cuboid, right? A very clear one. Quickly we'll move to the next one, children. Fifth one. Find the height of the cylinder whose volume is, is 1.54 meter cube and diameter of the base is 140 centimeter. Question is in meter cube. Let me keep also that in the meter cube here. So what it is, find the fifth one, right? Cylinder. need to write this here first. Yeah, I missed it. R is equal to 140 by 2. So 70 centimeter. 1 meter is equal to 100 centimeter. 70 centimeter is equal to how much? So 70 by 100. 0, 0 will go. I'll keep this 7 by 10 only. I'll not write it as 0.7. I want to keep that in fraction. Easy for me in further calculation. So radius is 7 by 10 meter. Write it here if you want. This is your calculation part. Okay. So you see, I know some things are very simple. You can do it orally, but 1 or 2 steps when you do, you will never go wrong. Yeah. What have they asked now? Find the height of the cylinder whose volume is given. So volume is equal to pi r square h. So volume is given how much? 1.54 is equal to 22 by 7 into r square, 7 by 10 into 7 by 10 into h. So 7 and 7 will get cancelled here. Then what we will do is, if you want, you can write this in this. You can write this as 154 by 100. Why? It is point, right? 2 decimals I have taken down. 2 zeros, 2 zeros. Can I cancel? Because if I cross multiply, we can do that. So 2 zeros also have gone. So what has finally left? 154 divided by 22 into 7 is equal to h. What is 22 into 7, children? 154 actually. 154 divided by 154 is equal to h. H is equal to 1 meter. Isn't the calculation so very simple we have done? Only by just removing the decimal here. See, why I cancel? Whatever is in the base here, if this 10 into 10 would cross multiply, 100 and 100 would get cancelled. That's what I have done. Height is 1 meter. Simple. We'll quickly move to the next one. Excuse me. Sixth one. A milk tank is in the form of a cylinder whose radius is whose radius is 1.5 meter and length is nothing but height, children, 7 meter. Find the quantity of milk in liters, volume in liters. I will write here. Find the quantity. Quantity is always in liters. Quantity means volume that can be stored in the tank. You can just have a small figure, right? So radius here is 1.5 meter, whose height is 7 meter. Let's quickly start. Volume is equal to pi r square h. So 22 by 7 into, if you want, I can write this as 15 by 10 into 15 by 10. Okay, and height is 7. 7 and 7 will get cancelled. So here multiplication, what you actually do it. Cancellation further, what you can do, multiply this or 2 5s are 10, 2 11s are. That's all further calculations. 5 1s are 5, 3s are 15. 5 3s are 15, 5 2s are 10. So 11 into 9 is 99 by 2. Okay. 2 4s are 8, 1 remainder. 2 9s are 18, 2 5s are 10. Answer will be in, children, meter cube. But we want answer in terms of liter. See here, I'll write here. 1 meter cube is equal to 1000 liter. This is the conversion. That is equal to 49.5 into 1000. So this is 49520 liters. Right? 3 zeros would come, but 1 will go in the decimal. Easy conversion. Remember this conversion here. 1 meter cube is equal to 1000 liters. Such basic conversions I expect you all to know. Conversion of meter to centimeter, liters, all these things. Seventh one. If the edge of the cube is doubled, how many times will its surface area increase? How many times will its volume increase? Such questions are always you can expect even in MCQs also. So know the pattern here. If the edge of the cube is doubled, so it is about the cube what we are writing. So let the edge of a cube be A units. Okay, so my data edge is doubled. Doubled in the sense A plus A, so edge is now 2A. So first part, how many times will its surface area increase? That's what I have written here. So surface area is TSA is equal to 6A square. 6, what is A children? 2A whole square. 6 into, it is 4A square, right? So 6 4s is 24. No, don't write this here. Okay, 6 into 4A square. I will write this as 4 into 6A square. Is it the same thing? 6 into 4A square. I wrote this as 4 into 6A square. Both are same. Therefore, according to the question, if the edge is doubled, its surface area is surface area 6A square only, no? Is increasing how many times? Surface area will increase 4 times if the edge is doubled. Okay. Second part what they have asked here is how many times its volume increase? Volume is equal to A cube. So which is nothing but 2A cube. So this is 2 2s are 4, 4 2s are 8. 8A cube. If the edge is doubled, how many times will its volume increase? Now here I see, if I tell its volume will increase 8 times the original one, no. If it is doubled, they are asking. Write this in the form, yeah, same thing you can form. Same as the original one it is, now. Correct it is. Its volume will increase. Its volume will increase how many times? 8 times. Right? Very clear about this concept? Remember this as an MCQ or a fill in the blanks type of question. And the last sum of this chapter, children. With that, we complete mensuration. Okay. Water is pouring into a cuboidal reservoir. So it is a cuboid. Okay. So water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. If the volume of the reservoir is 108 meter cube, find the number of hours it will take to fill the reservoir. Okay. First of all, we will write here, this is given as volume of the reservoir. Let's convert that in terms of liters, children. Into 1000 liters, if I have to make this as 108,103. Don't write, only directly will write it as liters. Because I can't say how many hours it is taking to fill, I need to know that in liters only. Next part, water poured in the reservoir per minute is equal to how much? 60 liters. That is why we converted that in terms of this. Therefore, time taken to fill the reservoir is equal to, see, water is poured in the reservoir in the form of 60 liters per minute. Volume is how much? This much. So I can say volume of reservoir divided by water poured per minute. Okay. Now since it is per minute, children, so what I will do here is now 1 hour is equal to 60 minutes. 1 minute is equal to how many hours? So it is 1 by 60 hours. So water poured per minute in terms of hours I have to write. Volume of the reservoir is 108 followed by 3 zeros followed by water poured per minute is 60 liters into 1 by 60. Why? Per minute we converted that in terms of hours. 0 and 0. So I can check this as 2 3s are, you cancel this, 2 5s are 10, 2 4s are 8, 1 0 will remain, 3 1s are 3 1s are 3, 3 8s are 24, 8 6 1s are 6 3s are 18, 0. So this is 30 hours. So time taken by number of hours it takes to fill the reservoir is 30 hours. Okay, conversion is very important here. So with this we complete the chapter mensuration. There are some worked examples also given. Go through the worked examples. I mean, you can solve the worked examples to get more and more practice and hang on this chapter.